In this lesson, we're going to talk about the idea of proportionality. In short, proportionality is this. You have two things, and if one increases by this much, this one increases by this much. Okay? If this one goes up the same amount it went the last time, this one goes up the same amount it went last time. If this goes up one more time, or the same amount it did last time, this one goes up the same amount it did last time. So in other words, it's a working ratio. Here's a ratio of, let's say, 1 to 2. Okay, so if I go again, it would now be 2 to 4. If I go again, it would be 3 to 6. And notice how this side increased by 1 every time, this side increased 2 every time. That amount of change is the same as the very first ratio of 1 to something. Now, if you remember a ratio with a 1 in it, that's a unit rate. So the unit rate in this idea was 1 to 2. All right, that idea can also be translated into the idea of a constant of proportionality. Like, what is the number that's being used every time? Well, in this case was 1, 2. 1, 2. So the idea is that it's raising by 2 every time. That's the idea of proportionality, is that whatever one value raises. So what we're going to do is we're going to take a look at this idea of proportionality and look at it in a specific situation. What we're going to do is we're going to go through 3 different visuals. We're going to go through a table, a graph, and an equation. So our simple situation we're going to check to see if this is proportional is, this is you, and imagine that you have a job where you make $8 for every hour you work. Now I'll tell you ahead of time, I'll give you a warning. The math we're going to do through this is not difficult, it truly isn't. But it helps to flesh out the idea of proportionality, so when you get other numbers that might look different, whether it be fractions, decimals, or just numbers that don't seem to follow a pattern, we'll be able to apply the same techniques and prove yes or no, proportional, not proportional. So when we start taking a look at our table, we have to first talk about the idea of dependent and independent. Now I want you to think about this. You have 2 items. You have money you earn and hours you work. One of them is dependent upon the other. So I want you to think about it and say in a sentence, which one depends upon the other? If I would say it this way, the money I earn depends upon the hours I work. And you have to ask yourself, does that make sense? What if I reversed it? The hours I work depends upon the money I make. Hopefully you say, wait a minute, this is what depends. Okay? The money I make is all dependent upon the hours I work. So if this is the item that depends, what we're going to call that is the dependent item. Okay? If this is what depends upon something else, that makes this the independent. Independent means you're allowed free range. You're allowed to be whatever number you want to be. Once you figure out what the independent number chooses to be, then the amount of money you make depends upon it. For instance, if I work 10 hours, then I can figure out how much money I make. If I work 1,000,000 hours, then I can figure out how much money I make. You can't go the other way around in this situation. The reason we brought up dependent and independent is because independent goes on the left side. Why? It's because that's the standards that were set when people started working with tables and developed common rules so everyone can look at a table and understand independent should be on the left, dependent should be on the right. So I'm going to fill in my labels. This is my hours, and this is my money. Now when I fill in my table, I'm going to start with the basics. If I work 0 hours, how much money will I make? It'll be 0. Now this idea of 0, 0 is very important because by definition of something that is proportional, 0, 0 must be part of it somewhere. So I'm going to save that idea more for later in our graph. But just understand, by definition, proportionality, there needs to be a 0, 0 in it by definition. And it makes sense here. If I don't work, I don't get any money. Okay, so I work 1 hour. Well, if I get 8 for every 1 hour, that's now 8. If I work 2 hours, that's now another 8, which is 16. If I work 3 hours, this is now another 8, which is 24. And now notice what we talked about with the hands moving up. This side's moving up by 1s, this side's moving up by 8s. And we'll do 4, which now is 32. And this list can go on forever, infinitely. Okay. So all we did was take our example and start calculating through in our minds. For every 1 hour, you make $8. Another hour would be another 8. Okay? Now, a quick note here, this is a special relationship because it's got a 1 in it. Well, anytime it's got a 1 in my relationship or my ratio, that's my unit rate. And again, we'll talk more about the unit rate in the graphing, but I just want to point that out in this example. Now, we said in order for an idea to be proportional, it needs to have a 0, 0 in it. So if I gave you this table and said, is this relationship proportional? All you have to do is look for the 0, 0 and say, yeah, it's proportional. What if you had a table that didn't have a 0, 0 in it? Okay, there's a way to figure this out. And I want to show you a quick calculation that shows, is a table proportional if you're just given the table? All right. So I'm going to come off to the side here. And the idea is this proportional, yes or no? The calculation is going to be this. The change in my dependent goes up top, over top of change of my independent. Now, when we talk about change, we're talking about how much different is it. So if I would say, what was my change from my age this year to last year? Well, it's a subtraction problem, taking this year's age minus last year's, and we know the answer is 1. So what we're going to do is a subtraction over top of another subtraction, which gives us a fraction. We know that fractions, the line is actually division. A fraction is a numerator divided by denominator. So let's take a look at actually plugging in some numbers. So I need the change of the dependent on top. So I pick 2 numbers. Now it really doesn't matter which 2 I pick. I can pick any 2. But again, we talked about the 0, 0 not being there, so I'm not going to pick the 0, 0. I'm going to pick the 8 and 16. Why? Doesn't matter, I just picked 2. Now what I'm going to do is subtract them. Now I want you to watch this. I have 2 numbers. I could subtract either way. I could subtract top down, but in this case, I'm going to go bottom up, and I'll explain more later. So what I'm going to do is take 2 numbers from the dependent side, subtract up 16 minus 8. I'm going to fill that in, 16 minus 8. And now I need the change of my independent. So I need 2 numbers from this side. Any ideas which 2 numbers I should pick that would make sense? I picked the 8 and 16. Which 2 numbers over here should I pick? Hopefully you say the 1 and the 2. Now that would make sense. They were paired up, 1 and 8, 2 and 16. I should pick them pairs matching up with another pair. It wouldn't help me much to pick a 5 and a 6. Again, I went bottom up. I'm going to go bottom up here. And this is 2 minus 1. Do my calculation. This gives me 8. That's my numerator. Denominator is 1. Well, guess what? 8 divided by 1 is 8. Now, all that showed was there was a change of 8 from this point to this point. From this ratio, 1 to 8, is a change of 8 from 2 to 16. That's all it showed me. If I can find that same relationship somewhere else in the table, then it's proportional. Because proportional is change the same amount the whole way through. whether it's at the very beginning or at the very end. So I'm going to pick two other numbers, 24, 32. I'm going to subtract going up. So 24 minus 32, and I said that backwards. 32 minus 24. I picked those two, I'm going to pick these two. 4 minus 3. Guess what? 8 over 1 equals 8. These are equal. Because the change was equal, this table is proportional. Now let's go back to why I subtracted going up. It said I need the change of the dependent side. Now I picked 8 and 16 randomly. The question is, why did I take, between 8 and 16, why did I choose to subtract this way? Why did I subtract 16 minus 8 instead of 8 minus 16? I'm going to let you think about that. You make your decision. Why do you think I chose that direction specifically? But this is how you use a table to prove or disprove if something is proportional.